Everybody, welcome to video 1.3. We're going to learn these 4 things. And I love whistling, so I'm playing this song. So, here we go. Make sure for your book that you read chapter 2. Alright, you don't have to take notes on chapter 2, but make sure you can define all of these. So put all of these words into your notebook and make sure you write the definitions. And then, as I'm going through the PowerPoint, you'll also hear me define them. So you might want to do this at the end, but just keep your ears open for these words, okay? So, classifying matter. Atoms are the smallest parts of matter that keep their own identity. That have like a chemical identity, okay? So, as smallest part of lithium that has lithium's identity is an atom, okay? Atoms make up elements, all right? If the elements are single atoms. And so if something's an element, it's going to be made up of atoms that are all the same, okay? Molecule is a chemical bond between atoms. Now, you might be thinking, okay, that's got to be 2 different atoms, but it could also be the same, okay? So I'll point that out when I look at the pictures in a second. Now, pure substances, there's only 2 kinds of pure substances. They are the same throughout, so that means each piece is exactly the same, and there are 2 kinds. Elements are pure substances because they're the same throughout, and compounds. All right, so elements and compounds are pure substances. So then we have to decide what's different between them. But what makes them pure is that they're same all the way through. One part is exactly the same as the other part. A compound is a chemical bond between 2 or more elements. Okay, so in a compound, you're going to get more than one element, but it's going to have a unique identity from the elements that make it up. Okay. In an element, it's all atoms are the same. Okay, so all atoms of an element are exactly the same as all the other atoms. Okay, they could be bonded together, but they're just all the same atoms. In a mixture, it's a physical blend of elements, or it could be some compounds thrown in there, or it could be more other mixtures. So a mixture is when you dump everything together, but there's no chemical reactions. They all have their own identity. Okay, so in a mixture, each piece is unique. Each piece of a mixture has its own unique properties. There are 2 kinds of mixtures, and the homogeneous is very well mixed, so that it looks pretty much the same, but it's still got individual parts. Heterogeneous is not well mixed. So you can see the different parts and distinguish them. Okay, so let's look at these pictures. All right, so are these atoms or molecules? Well, these are molecules because this implies a chemical bond. Now, is it a compound or an element? Well, this atom is different than that atom, so this is a molecule. But it also represents a compound because there's different kinds of atoms. Okay, what about this? This is same, atom. So this is atoms. And it's of an element because they're all the same identity. Okay, looking at this one. Okay, we have a bond, so it's a molecule. But it's an element because this atom is the same as that atom. Okay, what about this? Bond, so it's a molecule. When 2 atoms bond together, they make a molecule, some of them. And then this is also an element because those atoms are the same. Okay, what about all of this together? Okay, well, this and this are the same, but they're very different than that. So this is a mixture. So I circled the mixture. All right, what is it a mixture of? It's a mixture of elements. Here's why. This is atoms of the same kind. All right, so that's one element. This is a molecule, but this atom, and this atom are the same. So this is a molecule of an element. So we have 2 elements. All right, so here's how we can break it down. Pure substances can be compounds or elements. Mixtures can be heterogeneous or homogeneous. But the two main categories of classifying matter are mixtures and pure substances, and then there's categories under that. Okay, molecule or atom? Atom, single thing. Molecule or atom. All of these are the same, but this is a chemical bond, so this is a molecule. All right, looking at this bonded to that, bonded to that, bonded to that, so this is a molecule. Everything's bonded together to make one whole thing. But, yeah, okay, it's different atoms. Element or compound. This is an element because every atom is the same. This is also an element because those atoms are the same. This is a compound because we have white atoms, gray atoms, and red atoms, which would be 3 different elements, and they're chemically bonded. Okay, pure substance or mixture. So this whole thing, wait, this, and this, they're different pieces. So this is a mixture. Mixture. Okay, looking at this and this are the same as that and that. This is a pure substance because each part is the same. Pure substance, each part is the same. Mixture, different parts. Okay. Now, is this pure substance an element or a compound? It's a compound because the atoms are different. Okay. This mixture is heterogeneous. Heterogeneous. Here's why. If I take a spoonful, I might get some of that. If I take another spoonful, I might get that. If I take a third spoonful, I might get that. So each spoonful is not the same. So it's a heterogeneous mixture. Okay, pure substance or mixture. Physical properties. If it's pure substance, physical properties, all the same. All same. If it's a mixture, physical properties, each part of the mix has its own props. Okay. So, in a pure substance, the physical properties of the thing are all the same all the way through. In a mixture, each part of the mixture has its own props. So, what does that mean? Well, salt, water. That's a mixture. Here's why. Because salt tastes salty, salt stays salty, water stays wet. Water stays wet. So, the water and the salt mix, but they keep their own identities. That's why it's a mixture. Table salt is sodium chloride, NaCl. It has a chemical formula. That's one key to show that it's pure. All right. But Na metal changes. Cl gas changes to make the sodium chloride. Okay. So chlorine's a yellow gas. Sodium chloride's a white solid. Sodium's a shiny metal. Sodium chloride's a white solid. So the properties of the two elements that combine make new properties. It has own props. Table salt has its own props, okay, that are different than its elements. Water, H2O. Can we breathe in water and live? No. So the oxygen does not have the property of helping us breathe. Does water explode? No. So the properties of hydrogen aren't in water anymore. Okay, water is pure. It has its own identity, and all of water has the same properties. Table salt is pure, and it's a compound because it's got 2 elements. Water is a pure compound. Okay, not all water is pure, but H2O, when it's H2O, is pure. Okay, oxygen. Oxygen is O2. It's a gas. All of oxygen has the same properties, so it's pure, but it's an element. Okay. All right, moving on. Homogeneous or heterogeneous? Well, this is a mixture. There's some food coloring in there and some water. All right, but the food coloring still keeps its color orange. The water still stays wet, so it's a mixture. But it's homogeneous because if I pour out half of this into a glass, it'll still look like this part looks the same as this part, looks the same as that part. This is a mixture that's heterogeneous because if I take a spoonful, I might get 3 pieces of rice, and look, I can see the rice. If I take this, I might get 4 pieces of rice and 3 of these other things. Okay, so a heterogeneous mixture, you can see parts, you can see the parts, and you get different parts in each sample. Okay, homogeneous, you can't see the different parts, and you get the same parts in each sample. Okay, so what happens to molecules in chemical and physical changes? All right, so here's water. All right, H2O, 2 H's and an O, H2O. If it goes through a chemical change, notice what happens. The two O's are bonded to each other and you get oxygen gas. The two H's are bonded together and you get hydrogen gas. And so this has a different identity than the H2O. So a chemical change means the bonds are broken and new bonds form, and each thing that gets formed has a new identity compared to the water. A physical change is like melting or freezing or dissolving. All right, a physical change, melting, freezing, or dissolving, means these are still H2Os. They all look like this. All right, they look like this when they're solid. They look like that when they're liquid. They look like that when they're gas. So it's still the same molecule every time. So these kind of changes are physical because it stays H2O. This kind of change is chemical because the identity of H2O changes into a new identity with new properties. Okay? All right, so to review, elements and compounds are pure. Mixtures are physical blends of elements, compounds, and other mixtures. Most of what we see in nature are mixtures. Okay? Compounds are chemically bonded atoms of different elements. To be a compound, it has to be different elements. So they have unique properties from the elements, and elements can be made of atoms or molecules to the same atom bonded together called diatomic. Okay, so keep that in mind. There are two kinds of mixtures. Well blended is homogeneous or homogeneous, and heterogeneous. Okay, hey, I think we're done here. I just want you to go back, and I didn't talk about mass, so get that down. I didn't talk about volume. Physical properties are props that describe quality. All right. A physical change, we said melting, etc. All right. Make sure you can do that one in the video. A solution is a homogeneous mixture. I'm going to give you that one. All right. That's in the video. I'll do that one in class. In the video. All right. Or look at the book for these other ones. Okay, book. Go get it. All right. Hey, look, we're done. All right. Peace out.